In this lesson, I'm going to teach you how to sketch the graph of a function using all the different characteristics that I have described in my previous lessons. So let's start with this function. Sketch the graph of f of x is equal to x plus 3 squared times x minus 4. And so notice already that this function is given to you in factored form. And then you want to verify the general shape using technology, and technology just means using a calculator. Okay, so the first step in sketching any type of polynomial is to find the x and y intercepts. So starting with the x-intercepts are the zeros of the function. So once again, this function's already in factored form, so it's really easy to identify the zeros. They come from your two factors. So my two zeros, or my two x-intercepts, are going to be at x is equal to -3 and x is equal to +4. And those came from my two factors up here. Now you want to find the y-intercept. The y-intercept occurs when x is equal to 0. So you're going to evaluate your function when x is equal to 0, and that's going to give you your y-intercept. So f of 0 is equal to 0 plus 3 squared times 0 minus 4. Okay, so let's keep going here. F of 0 is equal to 0 plus 3 squared, which is 9, times 0 minus 4, which is -4. Hence, my y-intercept is going to be at 9 times -4, which gives me a value of -36. So there's my y-intercept, and these are two of my x-intercepts. Okay, so step 2, we want to find the behavior of the graph at the zeros, so in other words, the x-intercepts, using the multiplicities. So let's start with the 0, x is equal to -3. What is the multiplicity of that 0? Well, to find out, you go back to your polynomial, and you go back to the factor, x plus 3 squared. This squared means that this multiplicity, or this 0, has a multiplicity of 2. Okay, so since it has a multiplicity of 2, which is also an even number, we know at this 0, x is equal to -3, it is tangent at that point. So tangent at x is equal to -3. So that's what happens at that 0, but we have a second 0. So I'm going to move this down here. And our second 0 is located at x is equal to -4. So x is equal to +4. So what is the multiplicity of this 0? Well, go back to your original function. X minus 4 has a multiplicity of 1. Okay, so multiplicity of 1. Now that means that at that 0, it's going to cross at that point. So what happens? It crosses at x is equal to 4. Okay, so now that we know the behavior of the graph, we can move on to the end behavior of the graph. Okay, so to find the end behavior of the graph, we have to take a look at two different things. We have to look at the degree of the function and the leading coefficient. So let's identify the degree first. To find the degree, go back to your original function, and as you already know, it's given to you in factored form. Okay, and to find the degree of a factored polynomial, you're going to take a look at the powers of each of your factors. So we have two factors. This factor has a exponent of 2, right? And then this factor has an exponent of 1. Therefore, the degree of this polynomial is going to be 2 plus 1, which gives me a 3. So the degree of this function is 3. Now notice it is odd. So it's an odd number. Okay. And finally, we want to identify the leading coefficient. So the leading coefficient of my polynomial is the number in front of the function. So let's erase that. What is the number in front of my factors? Well, there is actually a number there, and that number is going to be a +1. So the whole key here is that the leading coefficient is positive. Okay, so we have two pieces of information here. The degree is odd, and the leading coefficient is positive. So what does that mean What does that mean in terms of our end behavior? Well, remember from my last lesson here, if we have a degree that is odd and it has a positive coefficient, that means my end behavior is going to end up in quadrants 1 and quadrants 3. Okay, so it's going to increase through these two quadrants. So I'll put here in my x-axis here, or my coordinate plane, we're going to mark off the end behavior. But we don't know exactly what it's going to look like. We just know that it's going to end in those two quadrants. Okay, so now that we have most of our key pieces of information, we're actually going to go ahead and sketch the graph. Okay? So start with your x-intercepts and your y-intercept. We have a x-intercept at -3, so 1, 2, 3. Okay, so -3. And another 0 at +4, so 1, 2, 3, 4. Okay, those are my zeros. Now let's graph the y-intercept, which is at -36. So I'm not going to count down all the way to -36. I'm just going to put it down here. So we know it's negative. It's way down there, -36. Okay, so we completed step 1. We graphed our x and y intercepts. Now we want to use the behavior of the graph at the zeros to figure out what our graph could look like here. So at x is equal to -3, we know that the graph is going to be tangent at that point. Okay? And then at x is equal to 4, we know that it's going to cross it at x is equal to 4. Okay? So we have tangent and crosses. And we also need to take a look at the end behavior. We have to make sure that our graph ends up in quadrants 1 and quadrants 2. Okay, so let's show what happens at x is equal to -3. Okay, so since we are increasing from quadrant 3, we're going to go up. Okay, we're going to go up, and it's going to be tangent at -3, and we have to show the graph crossing the the y-intercept. So we have something that looks like this so far. And then we have to show this type of behavior at x is equal to 4, and that is it's going to cross at x is equal to 4. So since it's going to cross it, you're going to go up, and we know that the end behavior is going to end up in quadrant 1, and that is an approximate sketch of what our polynomial function could look like. Okay, so what we want to do now is actually confirm this general shape using the calculator. So go into your y equals screen, plug in the original function, which is, let me just show it here. The original function is right on top there, and it's x plus 3 squared. And finally, we have a factor of x minus 4. Okay, so if we graph this, for now we'll use a Zoom 6 standard, and we'll change it if we need to. And we do. We have to show more negative y values. So go back to your window and extend your y min values to about -50. Yeah, let's try -50 for now. See if that works. Okay. And that's the general shape right there. And as you can see, we have it correct here. Like this is just our sketch right here. This is the actual graph on my calculator, and as you could tell, the general shape is similar, and so that we did that correctly. So that is how you graph a polynomial function using all the tools that I have taught in my previous lessons.